In this video, we're going to talk about how to solve the trig equation 2 cosine squared theta is equal to 2 plus sine theta on the interval 0 to 2 pi. Of course, we're going to include 0 if it's an answer because we have a bracket around 0, but we don't have a bracket around 2 pi, so we're not going to include the 2 pi if that were to be an answer. Now, the main struggle with this particular problem is we have a constant, we have a 2, and we also have a cosine squared theta, and we have a sine squared, or just a sine theta. And that wouldn't be a problem if we had, say, cosine squared theta and a cosine theta, but here, having two different trig functions going on, that's going to be an issue. And so what we're going to do is we're going to change out the cosine squared theta to be in terms of sine squared instead. And the method we're going to use for that is we're going to use the Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1. And we're going to solve that Pythagorean identity from your formula sheet for cosine squared theta, and then we're going to replace the cosine squared theta with whatever it's equal to, similar to what we've done before in proofs. And so in order to get the cosine squared theta by itself, we're going to subtract sine squared theta from both sides of the equation on the identity. And what that's going to give us is that anywhere we have cosine squared theta, we can put 1 minus sine squared theta in its place. And that's exactly what we're going to plug into the place right there in our original equation. So now rewriting the original problem, instead of having 2 multiplied by cosine squared theta, we're going to have 2 multiplied by 1 minus sine squared theta. And so now everything on the left-hand side is dealing with signs and just numbers. Sine is in like S-I-N-E and numbers. And then on the right-hand side, again, we just have numbers and the sine theta. And so now what we're going to do is we're going to distribute the 2 on the left-hand side, because what we want to do is we want to see if some things are going to cancel out. We want to be able to consolidate everything on one side and see about factoring. And so to do that, we need to distribute first. So distributing the 2, we get 2 times 1 is 2, minus 2 times sine squared theta is 2 sine squared theta. And that's going to be equal to 2 plus sine theta. And so now we have a 2 on both sides, so we can subtract 2 from both sides. And so those are going to cancel out. And I'm also going to add 2 sine squared theta to both sides. That'll give us 0 on the left-hand side. And we'll have sine theta plus 2 sine squared theta on the right-hand side. And so now we have everything on one side. We have 0 is equal to, and I'm just going to rearrange this in descending order, 2 sine squared theta plus sine theta. Now we've done a lot of work to get it to this point, but now that we have 0 on one side and we just have sines, a sine squared and a sine theta, what we're going to do is we're going to factor, because now we can. And so factoring out the greatest common factor, we'll still have 0 on the left-hand side, but we'll factor out a sine theta because that is our greatest common factor in this case. And if you divide sine theta away from 2 sine squared theta, you're left with 2 sine theta. And if you divide sine theta from itself, you're just left with 1. And so after factoring, that's what we end up with. Now what we can do is, since we have two things multiplied together equaling 0, we can use the 0 product property to set each of those equal to 0 separately and then solve them separately. So the first one, of course, will just be sine theta is equal to 0. And we'll look at that on the unit circle here in just a second. And the other one is 2 sine theta plus 1 is equal to 0. But if we subtract the 1 and divide by 2, what that's actually going to give us is that sine theta is going to be equal to negative 1/2. And so now we have two different things we want to look at. We want to look for all the places where sine theta is equal to 0 and all the places where sine theta is equal to negative 1/2. And so in order to accomplish that, we're going to go to the unit circle now, and we're going to keep in mind that sine theta on the unit circle, that's going to be our y values. So any of these terminal points we see, we're looking for the y values. And first of all, we want to match, we'll have a y value of 0, because our first equation is sine theta is equal to 0. And that's going to happen right here at 0, because our y value is 0, and it's also going to happen at pi, or 180 degrees, because again, the y value is the sine value on the unit circle. Now technically it happens again at 2 pi as well, but remember we have this parenthesis around the 2 pi, so that means we're not including 2 pi as a possible answer. We're stopping before we get to that. And so our solutions from our first equation right here are going to be that theta is equal to 0 or pi. So that takes care of that one. We're all done there now. So now let's look at sine theta is equal to negative 1/2. So again, what we want to do is we just want to skim around this unit circle. We want to find all the places where we have a y value equal to negative 1/2. And that's going to happen, first of all, right here at 7 pi over 6. Here's our y value of negative 1/2. And it's also going to happen over here at 11 pi over 6. Again, y value of negative 1/2. And so we have two more solutions. And coming from our second equation, we have theta is equal to 7 pi over 6 and 11 pi over 6. And again, we don't have to continue going, and we don't have to put the 2 pi times k where k is an integer, because we're dealing with only the solutions between 0 and 2 pi. And so there we are. We have four answers here. We have theta could be 0, it could be pi, it could be 7 pi over 6, or it could be 11 pi over 6.